This is the first lesson about ellipses and hyperbolas. And so in this part, we're going to cover the basics of ellipses and hyperbolas, which are also known in the math world as conic sections. And so they have to do, like if you look at the cross section of a cone, look at like the cross section. The cross sections are ellipses, which are kind of like ovals or specialized circles. And then hyperbolas are this part of it that's going out. So anyway, we'll talk about that. So on your notes, there's a lot of information in the first part of the notes. And so let's just kind of go through that real quickly and some definitions and things. So an ellipse is all set of points in a plane such that the sum of distances from P to two fixed points F1 and F2, or the foci, is constant. Now foci is plural for focus, okay? So what we're saying is that this ellipse, that blue part of it, that's where any point on that ellipse is the same point or same distance from there, or sorry, the sum of that and that one. So this is like F1 and F2. That sum would be the same as if I did from this point on the ellipse. If I did the sum from there and the sum from there, so this F1 and F2, those distances would be the same. It wouldn't matter if I did it from any point on the ellipse. It's going to be the same sum of the difference or distances. So that's what an ellipse is. It's a set of all of those points that have that special quality. Okay, so the standard equation, so in all of our other stuff we have standard equations. So we have standard equations for a linear equation, y equals mx plus b. We have a standard equation for circles and for quadratics and things like that. So like a quadratic is y equals a times x minus h quantity squared plus k. And so we have different equations that tell us what kind of a situation we're looking at. And so for an ellipse, this is it. And so it's got the x squared plus the y squared, okay? And then we've got these denominators, a squared and b squared. Now, a squared and b squared, they could be the same numbers or they could be different. One thing that is a giveaway, though, is if you have both x squared and y squared and a plus sign, okay? Now, the equals 1 part, that's how it needs to be. If it's in standard form, it needs to have a 1 right there, not any other number. If it has any other number, you're not ready to graph it or to work with it. So you need to keep that in mind. Okay, we've got a couple of axes. So the major axis in an ellipse is the longer axis determined by A or B. So in this picture that we have up here, this would be my major axis because it's longer than the vertical axis. So that would be the minor axis. So we've got a major and a minor axis, and it's just determined whichever one's longer. So if a squared is, say, 25 and b squared is 16, then the x-axis will be the longer one. Okay, so that'll make more sense as we go along. A lot of this stuff in the definitions is going to make a lot more sense as we go further. The major axis length, so how long is this major axis? It's going to be 2 times whatever a is. So like if a squared was 25, that would mean a is 5. And so 2 times 5 would be how long that axis is. And same thing for the minor axis. If a squared is greater than b squared, then our vertices, and I'm just noticing I spelled that wrong. Whoops. Anyway, the vertices are going to be plus or minus a and then 0. So for this example up here, my vertices would be plus or minus 5, 0, and negative 5, 0. The co-vertices, those would be on the minor axis, would be 0, and then like let's say b squared is 16. So it'd be 0, 4, and 0, negative 4. So those were our vertices and our co-vertices. Also, if a squared is greater than b squared, then the way that we find the foci, or each focus point, is done by doing a squared minus b squared equals c squared. So it's kind of like the Pythagorean theorem, but it has a subtraction because we're looking at the differences. Okay, so again, we'll do some practice with that. Okay, so if the equation y squared plus x squared equals 1, and with the plus, it doesn't really matter which one is x squared and which one's y squared. But what that would be saying is usually like the first one that comes is usually for the major axis. So usually we look at it as being a squared is bigger. And we'll see some examples where we could rearrange it. But if that was the case, then y is the major axis if a squared is greater than b squared. So if a squared is bigger than b squared, then the y would be the major axis. So you would have an ellipse that was going like that. Okay, so what happens if a is equal to b? So if you have something like x squared over 9 plus y squared over 9 equals 1, what is that? That means that your major axis is going to be 6 and your minor axis is going to be 6. And so basically you have a radius of 6. Or sorry, not a radius, a diameter of 6. And so it's going to be a circle. And if you think about it, the way that we've learned, you could multiply this entire side by 9. And you get x squared plus y squared equals 9. And that's an equation of a circle. So if a is equal to b, then you do have a circle. A circle is a special case of an ellipse. Okay, now with other graphs that we've done, you can translate, so slide it up and down, left and right. And a translated ellipse equation looks like this, and you'll notice we've got the h and the k. Again, we've seen that before. So the h is going to go left or right. And just like before, if it says x plus 2, it's going to go left 2. And this one is going to make it move up or down. And so the signs go opposite of what you think. So the center of your ellipse ends up being HK. All right. So how do you figure out the vertices and the foci of a translated ellipse? Okay, so HK is going to be the origin, it's the center. So you're going to start with your HK, and then from there, you're going to use your A, B, and C. So if I have an ellipse that's, starting right there, I treat that as my origin, and I go like, 3 that way, 3 this way, and I, make my ellipse from there. So we're going to look at some practice with those types of situations. Okay, now the next thing we're going to do is we're going to practice. So go to the page of your notes where we do some practice with ellipses. So we're going to do practice with ellipse, then we're going to talk about hyperbolas. Okay, so we're going to identify the center, the major axis length, the major and minor vertices, and the foci of each ellipse, and then sketch the graph. Okay, so it says x squared plus y squared. We've got 16 over 25. So notice that x is, or a is less than b. Okay, that means that my ellipse is going to be longer the vertical way, and so I already know that. And my center is going to be at 0, 0 because it's x minus 0 quantity squared. So I'm going to start with my 0, 0 is going to be my center. So I'm going to write my center is 0, 0. Okay, I know that a is equal to 4 and b is equal to 5. And so what that means is it means that I'm going to go on the x-axis 4 in both directions. And I'm going to go on the y-axis 5 in both directions. And when I connect it, that's my ellipse. Now keep in mind you're not doing a diamond here. It's really hard to do a freehand ellipse very well, but do the best you can. So our major axis is the y. And how long is it? It's 10 because it's 5 in both directions. Okay, that's the major axis length. Okay, the vertices. So the regular vertices are going to be on your major axis. And so those vertices are 0, 5, and 0, negative 5. The minor vertices, or the co-vertices, are going to be the 4, 0, and the negative 4, 0. Okay, now how do you find the foci? The foci is, remember, it's going to be the a squared minus b squared equals c squared. And the way that I remember that is because there's a plus right here, I'm going to do a minus right there. So I'm going to take 16 minus 25, and I know that's going to come out negative, so I'm just going to do it the other way around because it doesn't matter. So 25 minus 16 equals c squared, so c is equal to 3 because c squared is 9. So what that means is I'm going to start at my origin, and I'm going to go 3 in each direction on the major axis, and those are my foci. So foci 1, foci 2. So my foci points are going to be 0, 3, and 0, negative 3. And so those are all the critical components of an ellipse. So let's try another one. Okay, so why don't you pause the video and just see if you can get this based on what we've learned so far, and then you can turn it back on and see if you did it right. Okay, my center is going to be at 0, 0 because there's no translating going on here, okay? My A is 6, B is 4, because the square root of 36 is 6, the square root of 16 is 4. Since this one is bigger, it's going to be on my x-axis is my major axis, so I'm going to go over 6 in both directions for my ellipse. My minor axis, I'm going to go up 4 and down 4. And then I'm going to try to make that into a nice looking ellipse without it being too pointy. All right, so let's write some things. So my center is 0, 0. My major axis length is the y one, or the x one this time, and it's 6 and 6, so it's 12. My major vertices, or just my vertices, are going to be 6, 0, and negative 6, 0. It does not matter the order that you list those, so you could say the negative 6, 0 first. Co-vertices would be the 0, 4, and the 0, negative 4. Now, if you've got points like that, it is perfectly fine if you would rather just write plus or minus 6, comma 0, and 0, plus or minus 4. Okay, so if you've got points like that, you can do it like that. Okay, for the foci, I'm going to take my a squared minus my b squared, and that's going to be my c squared. So 20 equals c squared. So c is equal to the square root of 20, which is 2 square root of 5. So on this one, you're going to need to get a decimal approximation for that. And so your decimal approximation, you need to know like how far on your axis do you go. And so I'm going to get my calculator and find that 2 square root 5 is about 4.47. So I'm going to go on my major axis about 4.5, and those are going to be my foci. And so labeled that with an F, both of them just an F, and then you're going to say you could do plus or minus 2 square root 5 comma 0, or you could write them as two separate ones. But when you write the foci, do the exact amount. Okay, so what I've got coming up are just some more examples with ellipses, so you can do as much of this or as little of this as you feel like you need to. So I'm going to just quickly go through the rest of the examples. So for this one, my center is also at 0, 0. I'm going to go over 5 on the x-axis. I'm going to go up and down 7 on the y-axis, which will be my major axis. My foci are going to be 49 minus 25. And so 49 minus 25 is 24. And the square root of 24, that's going to be 2 square root 6. So my foci are going to be 0 plus or minus 2 square root 6 because it's going to be on the y-axis. So 2 square root 6 is about equal to 4.89, so almost to 5. And so that's where I'm going, almost to 5. So that's where I'm going for my foci, so I'm going to label those. Okay, my center is at 0, 0 still. My major axis length is 7 and 7, so it's 14. My vertices are going to be at 0 plus or minus 7, and my co-vertices are going to be at plus or minus 5, 0. So you want to make sure that you know the difference between your vertices and your co-vertices. The co-vertices are going to be your shorter dimension on this for ellipses. That's how you do that. Okay, number 4. Okay, same thing. I'm just going to go through it quickly and you can watch it or not. So I'm going to have 7 on my major axis. I'm going to go 5 on my minor axis. So this is actually just like the previous problem, except it's turned the other way because I just reassigned the A and the B. The foci is going to be 49 minus 25, and so we just did that one, and so it's going to be 2 square root 6, and so 4.89 or so. But this time I'm going on the x-axis. So those are my foci. So my foci are going to be plus or minus 2 square root 6, 0. My center is at 0, 0. My major axis length is still 14. My vertices are going to be at plus or minus 7, 0, and co-vertices are going to be 0 plus or minus 5. Okay, the next example, now we have some translations going on. So what's going to happen this time is my center is going to move. So my center is going to be at -3, +4. So remember how the signs work when you're doing something like that. So I'm going to go to -3, +4, and that's going to be the center of my ellipse. So my major axis will be like that now, and my minor axis like that, or vice versa, depending on which one is bigger. So in this problem, I'm noticing that the 4 that's going with the x, that's going to be on the x-axis, and it's only 2 because the square root of 4 is 2. So my minor axis is going to be on the x. My major axis is going to be square root of 9, which is 3, so 3 in each direction. And so my ellipse is quite a bit smaller this time. Just try to make it look like it has curves and not corners. So my major axis length is going to be 3 and 3, which is 6. My vertices, they're not going to be 0, 7. You need to get the ordered pair right. So this is -3, +7, and this is -3, +1. And so you need to make sure that when you get your vertices, you're getting the right location and not bringing in the zeros, because that's not where it is on this one. My co-vertices or my minor vertices are going to be like right here. So I'm going to have -1, +4 and -5, +4. Now for the foci, I'm still going to do the 9 minus 4, so the a squared minus b squared, and so that's 5. And so my foci will be √5 away from the center. And so if I look at my center, I'm going to go √5, which is a little bit more than 2. And so it's going to be like right there and right there. So that's where my foci is going to be. So as far as what do you write for your foci ordered pairs, we're going to write -3. And then we started at +4 and we went up √5. So I'm going to say 4 plus the √5. And then for the other one was -3. And then you start at 4 and you subtract the √5. Okay. Now alternatively, you also could write -3, comma, and then 4 plus or minus the √5. So you could do that. So one thing you need to make sure you do is if your vertices are not, or if your center is not 0, 0, writing down your vertices and your foci is going to be a little bit harder to do. You've got to pay attention to where you are and where things are on that ellipse. Okay, another example, number 6. Again, we've got this translation going on, and so I'm going to go to -1, -1, that's my center. And then I'm going to, on my x-axis, go 5. And then on my y-axis, the square root of 36 is 6, so I'm going to go up 6. And I'm going to go down 6. And so when I make my ellipse, my major axis is going to be this one right there. That's my major axis. So my center is at -1, -1. My major axis length is going to be 6 and 6, so 12. My vertices are the one on the major axis, so it's -1, 5, and -1, -7. My co-vertices are the one along the x direction, and so that's going to be 4, -1, and -6, -1. For my foci, I'm going to say 36 minus 25, which is 11. And so the square root of 11 is how far I'm going to go. So if I get my calculator and I find the square root of 11 is 3.3. So from my center, I'm going to go up 1, 2, 3 and a little bit, and down 1, 2, 3 and a little bit. Those are my foci. So my foci is going to be at -1, and then I started at the green and I went up from there. So it's going to be -1 plus the square root of 11, and -1, -1 minus the square root of 11. And so that's how you graph an ellipse. That's how you read the information from the equation. And so then the next part is going to be the hyperbolas.